Well, hello there. Welcome to my channel. Get ready for a mind-blowing physics ride. The net electric field due to the positively charged disk will be along the z-axis due to symmetry. Now imagine you are at point P and you have a torch. Now you switch on your torch and point randomly at the disk. Now you see a round two-dimensional shape forming on the disk as light cannot pass through it. This shape is what we call an area element ds, and the 3D angle that the beam of light surrounding the shape makes with the torch or the light source is called a solid angle, d omega. Now we are ready with our tools to find the electric field at point P. So if the shape on the disk increases in size somehow, the solid angle increases, and when the beam of light encompasses the whole disk, we in return will be able to measure the electric field at point P. Now let's derive the electric field. We can write the increment in electric field dE along the z-axis so that dEz equals dE cos phi, and dE is equal to sigma ds divided by 4 pi epsilon naught r squared. Now we can write dEz as sigma ds cos phi divided by 4 pi epsilon naught r squared, and d omega is equal to ds cos phi divided by r squared. Hence we can write dEz to be equal to sigma d omega divided by 4 pi epsilon naught. So after integrating, we get E equal to sigma omega by 4 pi epsilon naught. Now this is the electric field at point P. You being at point P want to know the electric field at the center of the disk. And you need not do everything all over again. You'll just have to transfer yourself from point P to the center of the disk, and you'll immediately realize that the solid angle formed by the beams of light from the torch you're holding is widening with every step. And as you reach the center, the angle is at its maximum, which is 2 pi. So what do? You plug the value 2 pi in the electric field equation. That is, E equals sigma omega by 4 pi epsilon naught, which is sigma 2 pi by 4 pi epsilon naught. From here, you get electric field at the center of the disk to be sigma by twice epsilon naught. What if we imagine a hemisphere and want to know the electric field at the center of the base of the hemisphere? Again, we'll take a torch and align ourselves at the distance along its vertical axis and switch on our torch. We already have our equation, that is E equals sigma omega by 4 pi epsilon naught. Now we know that the solid angle at the center of a sphere is 4 pi. So from a common understanding, we will be compelled to say that omega must be twice pi, and you are right. In a way. Why? Because if there had been no charges, omega would be twice pi for the hemisphere at the base center. As there is a continuous distribution of charges on the surface of the hemispherical shell, only the cosines of the electric field vector survive as the rest cancels, and omega becomes pi rather than twice pi. So the electric field at base center becomes sigma pi divided by 4 pi epsilon naught, which is sigma by 4 epsilon naught. And this is one way to find the electric field at the center of a hemispherical shell.